All right, back to Made of Wires, where we're just dropping 26% of the frames instead of 70. We'll see if this goes better this time. If you're not familiar with the channel, we're decompiling Castlevania Symphony of the Night, and you can go to soten.z.dev to learn more. I am just a contributor who likes to do this with all the people that show up. And if you want to show up Monday through Thursday, I'm here. I won't be here next week, but Monday through Thursday, I am here. Usually for about an hour or so. Today we're going to work on the clock tower. We imported that yesterday and started working on a function. We'll get back to the function, which was the Harpy entity. But there was a problem. So usually I don't import the PSP version of the game. It's not something that I'm terribly interested in. Not as much anyway as the PlayStation version of the game. But there are nice things about the PSP version. It makes it much easier to decompile the PlayStation version because it was compiled without optimizations, and so the assembly that gets generated is much cleaner. So what I usually do is have a dumped version or disassembled version of the PSP version kind of on the side that I look at, but I'm not actively decompiling that one. I just use it as a reference. During the Richter overlay, there were a bunch of cases where I thought it would be nice to have the symbols available, and that would have been nicer if I would have updated the PSP version as I was going through the PlayStation version as well, but that didn't work out. So I decided to do both this time, and it ended up being a small issue. And I want to do a little tooling work first, and then we'll get back to the Harpy entity. So the issue is, I think we have a slight misunderstanding of what the MetroWorks header, what its format was and what the values in that mean in our makeconfig script. Makeconfig goes and looks at the details of an overlay, tries to assign symbols for different parts of that overlay based on other things that we've decompiled previously in a couple different ways. And part of that is looking at the overlay metadata that comes with an overlay file, and then trying to reassign some of the values based on the data in that overlay. And some of those assumptions I think are a little off. And so I'm going to try to fix those and see if we can get a better starting point. And I'll go over how I plan on doing that in just a second. So first I'm going to go to the Get MetroWorks overlay header function. And what I want to see is, do I agree with what this is? I've made a slightly different version of this. And what did I call this? MWO dump? Yeah. And so we know what the format of this file is, but I think interpreting how that is used was a little off. So I want to see what this looks like and if we have the correct things. Fortunately, we have some other metadata from other places in the the PSP version of the game that can help us align our offsets and addresses correctly, and I think that'll end up hopefully saving us. And if not, if we can't come up with a generic method of doing this, then minimally we can kind of force it for this particular overlay and come back to it later. Maybe add some notes going forward. So we have this splat config. Splat is used to break the overlay file up into a bunch of pieces. It uses SPIM, which is a MIPS disassembler, to give us the machine code as well as any data that came from it. So I'm going to open the generated config. NZ1 is what I want. And I have some notes down here about where data, RO data, etc. are. And a couple weeks ago on the stream, we added file magic so that we can just run file against these and get most of this data. What is wrong, I believe, is where this VRAM address is, and unfortunately this VRAM address affects basically everything else. Another thing that gets generated is a symbol table. I really want to type 0 there. And all of these addresses for this symbol table are based on the offset in the file plus this VRAM address. And so if we choose the wrong VRAM address to start, all of these are going to be wrong. However, we do have one address that we know for certain. I'm going to get rid of the entity IDs. And it's this NZ1 load function. And the reason that we know this for certain is because all of these addresses are exported and stored in ps.elf, which is the main game file for this on the PlayStation, and it needs to know the address to call or to jump to initialize this. So for every stage, we have some address that is going to be the load function, and we're looking at NZ1 here. So we know for certain that the NZ1 function is going to be here at this 3460 address. And if we know that, we can find where that function is. Make sure that I have the right value there. We can find where that function is and what its offset is in the file, and then make sure that we have the correct VRAM address here to make those two things line up. So I'm going to look at what NZ1 load looks like now. I think that I have it extracted correctly, but I don't think everything else is. And that's because this file or this VRAM address originally was incorrect. So we're going to do ASM PSP EU is where this is extracted to. Stage NZ1 non-matchings. We only have one file right now, which is 80, and so we should have an NZ1 load function. And there's a couple things in here that we want to look at. What does NZ1 load look like? Do we have the right instructions here? Does it look like a valid function? And it does not. So every function, for the most part, is going to end with this JRRA instruction, usually with a no-op afterwards. In this case, the issue is we have a bunch of labels here which indicate that a jump table is trying to jump to various parts of this that won't exist. We also have a call to play sound effects. Play sound effects is not something that is commonly done in a load function. Let's look at what a load function should look like. We have a specific PSP. Let's look for sen load. I'm pretty sure sen is already decompiled for PSP. No, it's not. So let's look for other load functions. Are we not doing that? So is this a shared function? That would be interesting. It could be. Oh, we won't have underscore load. It'll be OVL export load. That's why it's not showing up. OVL export gives us the prefix that we need. All right, so we have a bunch of these here, so we can just choose any of these stages. The latest one that's been done is probably DAI. So this particular function has some calls to get lang at. The important thing that all of them are gonna, it's a little different than other ones that I've looked at. Let's look at CHI. DI is chapel, CHI is, this is more typical. CHI is, I can't remember. Let's see, can I grab the stage wiki here? Abandoned mind. Abandoned mine, not mind. Let me get back to this other one. I keep going to the wrong page. Most of them are like this. You call init entity IDs, and so that it will give us the address for init entity IDs as well. And that address is baked in, and so we know it's correct as well. We set a pointer called PFN entity updates, set a couple other global pointers, which again gives us some symbols that we should know. Always call this function, I don't know what it does offhand, and then do a mem copy. So we should have a function that looks very similar to that somewhere in. And so looking at the mem copy, for example, that's not a function that's called very often. And so we will have a symbol for that that we can search for in the disassembly. And the rest of this then we should be able to figure out. So we have that and then two function calls. So let's go back here. So I'm going to look for mem copy in this list. We have two of these. I might clean first. This is showing up in matchings. Let's look at the matchings version. There's nothing decompiled here yet, so it should not show up in matchings. But this does look like the correct. So here, the VRAM address is wrong, but the offset, I believe, is correct. And to confirm that, we can look at another stage overlay as well that is correctly aligned. So this one was CHI. Usually we don't have symbols for the matched version. And so we start with offsetting the stack pointer and then a jump to our function. And so let's just confirm that that's what that looks like. Yeah. Offsetting the stack pointer, jumping to the function. So I think this is fine. So our offset here is IBDE0. That's our offset in the file. So I'm just gonna make a note of that here. Now I'm gonna take, we should be able to determine the VRAM base now. I'll take this address, grab my calculator. It's somewhere. There we go. Take the address, subtract IBD0. And this is the base VRAM address that we should have. And let's do a diff here. Missing the 0. I'll put the 0 in for alignment. So the base VRAM address that make config had was at 700 and not 680. So what I would like to do is keep all of these as notes and basically delete these files and have make config regenerate these, but with the correct VRAM address. And the easiest way to do that, I think, would be to force it. I don't think I want to take the time. The right thing to do would be to fix how it's calculated. We can look at it and see which one. My Python isn't the best, not a language that I'm terribly comfortable in. And there's a lot of side effects to different things that I don't really want to get into at the moment. So I'm just gonna, I'll make some notes. We're looking at NZ1. So thinking about this other ways, where should this be and how could we determine it? So I wrote, this is, the same data is in files as well, but I wrote MWO dump, which might have a nicer output than file. And we can see what MWO dump says. I should update MWO dump to generate the splat config. I think that would be nice. So this says our VRAM is at 7680. And actually thinking about this, I have not updated this since I learned a little bit more about how the alignment works. But I do want to see if that's... So yeah, I think we should always use this. I think it's being calculated in tools. So I think that's all the info that I need. So I'm gonna get rid of this. And get rid of this. So let's go to make config. All right, so this grabs VRAM, and the issue is here where VRAM CStart is getting a plus 80. I was talking to Project Oblivion about this related to weapons, and he said that he's seen cases where sometimes the 80 is necessary and sometimes it's not, and it wasn't clear why and when. The other part of this is the data start alignment is done differently than Splat can handle. Data does start at offset 80 no, that's not true. Data starts at offset 40 in the file, but the alignment is at 128 byte boundaries. And so we get padding from offset 40 to offset hex 80. And that that padding size is attributed to the data and text sections. So we have to account for that. So this really should be 40 here. And then I'm going to get rid of this as well. I think that this is enough to give us the correct offsets, but we'll see. The other thing that I want to do is when matches are being created, let me find where that's happening. here I want to, I know what that NZ1 load offset is, and so I want to stick that in there first. So I need to figure out what that's going to be. So here in the symbols, I'm going to, before any of this happens, I'm going to add a symbol. We have our splat config version, OVL function. What is this? Oh, no. This is going to be NZ1 load. Again, just forcing this for this one. The VRAM offset, again, we got that from ps1.elf. It's going to be this here. And this table I should just bake in to make config since we have it. This is going to be, the source is ps.elf, and I don't think we have any other options. So I think that is fine. I'm going to move that to where do I want that? I'm just going to put that here. Do we have all of those things? Splat config version options, yes. Okay. So I think that's good enough. Let's try again. Tools. Sorry. Version is PSP-EU. Tools, make config, NZ1. And let's see if that works. All right, so getting the entity stage table cannot make assumption of entity dummy at this particular address. I don't know if that is reasonable or not. We'll go take a look. We did get symbols hydrated. Let's see what those are and see if we like what it came up with. I'm gonna undo that. So the important things here are, where does data start and where does RO data start? I'm gonna grab those grab these bottom 4 lines. Actually, I'm gonna grab everything at the bottom and we'll redo that. So I have data starting at 49B8 versus 4980. The 4980 again is a misunderstanding of how the length attributes in the overlay are actually being used. So I think that can be fixed. And then the RO data, we'll look at RO data as well. Let's see though if that was enough. NZ1 load. I don't like that. I'm gonna do this one more time. I feel like this was cached. Let's try one more time. And I really don't want this to get cached. I want to make sure that it's generated fresh. That is an issue with some of this tooling, is that it caches things in unexpected ways. So let's try one more time. What I'm expecting is an NZ1 load symbol to be there, but the symbol should, yeah, say source pself, because that is what came from that make config file. So I'm a little happier about this. And I'm gonna make sure that I have my extra data here, comment these out. So I think the data and RO data and even BSS are wrong. I think BSS basically should be at the end. And we know what BSS starting address should be. It should be this 81180. And that shows up correctly, actually, so that's fine. I guess I'm okay with that. So the next question is RO data in the correct place? That's possible. And is data in the correct place? So the way we can figure that out is by looking at them. So we want assembly, DSP, STNZ1, data, and we're going to look at $24980. This starts with a bunch of other stuff. I'm going to look at one more thing. We're going to look at non-matchings, and we want the last function. Not the JTable, we want the last function. Yeah, this one here. And it should end in a JR and a NOOP. And that looks fine. And the question then is this actually data or are these instructions? And the easiest instruction to find is the jump return with the RA register as an argument. And so we can look, is that in here somewhere? And it is. So there's actually an extra function here because of the misalignment calculation that's not showing up. So the earliest data can start is 249B8. And this padding then will be part of data. It'll be aligned to 24A100. So you could say data starts at 24A100. That's not the way MetroWorks would say it. So I'd rather have to put padding or other stuff in there and say that it starts earlier. But then the last part of this is, where is RO data? And MetroWorks doesn't treat RO data separately from data when it gives us the metadata. So we have to figure it out. Fortunately, nothing that I've done so far will affect the generated C file at all, and I think this will work, and hopefully it will be correct this time. So let's look at the RO data and see if we agree with it. The most important thing that's going to be in RO data is the jump tables. There might be strings in here as well. I almost would start RO data, and this is what I chose. No, I didn't. Looks like I chose 58. I would probably start it. These look like addresses. If they start with 0924, I would guess that they're jump tables. Yeah, so I would start at 49958. These other ones might be strings. They don't have... Oh no, these are... Sorry, that's the offsets. These don't look like addresses to me? This does, possibly. Oh no, these are addresses too. 0924, 0924, 0923, 0923, 0923. So these are addresses as well. 0923. So these, I agree that this should be RO data. And let's look at the end of 24980 and see if there's any more of those. It doesn't look like it. So this this boundary was chosen by make config. It goes and looks at, it knows what the VRAM offsets are, and so it goes and looks for those. It looks for addresses or things that look like addresses. So I'm actually okay with where it chose that boundary. I don't know why I came up with a different one before, but I'm okay with this. They might be, it should be things, I'm pretty sure it's constrained to the text section, or what it thinks is the text section, but we know that the text section is slightly wrong. So we'll see if this works. So I think that this should be fine now. There is a C file that gets generated, and we can look at that and see if we think that that is fine. We're going to be missing one function here because the split was in the wrong place. So we do need to figure that out. So data, we're looking at the original 24980, and nope, I need to look at the beginning of this, sorry. And where does that, so that function offset is this BF8, and so that's going to be the automatic function name, and so we can put that in here, and Splat will find it then and create a function at this address. So I think that's it. We'll see if that works. Export the version as PSPEU and make. Cross our fingers. Let's do a split first, just in case. I didn't think that would be necessary, but oh, not again. There we go. Okay, so there is a function, it says, that does not exist, and that is the one that we just added. So let's see if that's true. And we could do a clean on this as well and try to get it to exist. ASM, PSP, ST, NZ1. Non-matchings. It might show up in matchings. We'll see. It's not showing up in matchings. That's good. Non-matchings, NZ1, 80. Okay, so it's not showing up here yet. Why? Let's look at the preceding function and see if it's possible that this was part of the preceding function and it was just a continuation of that function. That could be. I might have misinterpreted that. That'd be nice. Hey, Roaming, if I didn't say hi already, good to have you back. Oh, it is. Yeah, it was just a continuation of that other function. So we don't need another one. So I'll get rid of that. And hopefully that was it. Missing something. no such file or directory. So our this is another issue with make config, and I'm surprised that this hasn't bit other people. Maybe people just aren't importing things as often as I do. This should be NZ1 PSP /80. I still have make config open. So this is .ro data. And where is our C file being added? This seems like something maybe that I screwed up at some point. So that should be checked in. The other stuff I'll have to do more testing on, but at least that part should be fine. Try it again. Fingers crossed. Yeah, and this is what I was having trouble with earlier. Oh, we do have one other issue. No, I think that should be fine. So we have multiple definitions of our jump tables. And let's see why. I'm gonna do a clean and see if that helps at all. And if it doesn't, we'll move on. We should be able to find the PSP version of the function now. Yeah, we have this as well. Let's look at one of these and see if we can. So the offset 0 is strange to me, but we'll look at the other ones too. I'm actually thinking a little further through it. We don't have to put all of these symbols in to make config. We could actually put them into the symbol table, and that's probably not the worst idea. All right, so I want to look at the assembly for this first function. So we have our jump table embedded, which is what's expected. And what this is saying is that multiple things refer to this 9244CD0 label. So it's not that we're worried about this. And so this is an issue now as well. This particular jump table is being associated with this file, but it actually has nothing to do with this file. Because these addresses are not part of this file. And why is that? I'm not quite sure. Oh, this is not a jump table. That's what the problem is. This shouldn't be in data or RO data. It should be just part of data. And I think that's going to be the issue. Yeah, I think this is just data. Or maybe not. Entity relic orb. No, it's the address. That is part of this function. But the jump table should not be associated with this function. So it's in the wrong place. And this one is in the wrong place as well. We do only have a single definition of it, however. And let's look at who is referring to this jump table. Yes, all these addresses are off as well. So something else funny is going on. It's not clear to me what specifically it is that is going wrong. That is a bummer. Let's try to... the addresses for the jump tables are baked in, and so we know that they are correct. So at VRAM address 09281008 should be the jump table for this function, but the addresses that it's pointing to here are not the correct addresses. So we can shift those. I would think shifting them by 80 bytes one direction or the other might help. If we shifted them back 80 bytes, these addresses are in completely the wrong area though. 24E61823. Yeah, this is... All right, so maybe, are these not? These are not jump tables. Yeah. Okay, so this is wrong. These aren't actually jump tables. These are lookup tables for other functions, but not jump tables. So that means the RO data offsets are wrong. And so this is in the 49A2C range. Oh, isn't this fun? So let's look at NZ1 PSP80 RO data. So these being treated as data, I guess, is a good hint. Let's go down to the first one that was originally given a jump table designation. And we want to see if any of the symbols that we currently have match up here. So we're going to look at non-matchings and see what that is. We have a label here. So 3DDO is not, I do not believe is correct. I don't think CDO, oh, and CDO is a continuation of this, so I don't think that's correct either. Let's look at this next one. We were looking for what? what did I search for? 7E4. So we have our jump table that we know about. Showing up, yeah, in RO data, that's fine. And then we have this 74 referenced here. And let's see if that label, this looks like the right thing. Okay, so I think 499B8 is where RO data is going to start. Is that what? Make config figured out? Possibly. Not wrong one. This is easier to do in PlayStation when we have less data. Oh, look at that. That's what I came up with. No, it's not. It's not what I came up with. Never mind. All right, let's try this one and see if this works any better. Oh, I should have loaded all the things. This is actually a good sign. Got past building that. So the worst that can happen now is that we don't build. I'm gonna do it again. I don't think the sim export file would have been regenerated. Okay, a few additional ones. The L0 is slightly concerning. All right, so this is possibly another case where maybe these are not actually jump tables. So we're a little further, got it. We're a little further down. So 499D8, I'm gonna go down there. And if these are not, if this should be RO data and it's not, oh, here we have another one down here. The zero is actually, oh, zeros are fine. Where is the STNZ1 getting generated? That just means the jump table was padded. Hey, Supreme Quetzal, good to have you. Okay, so we do have several functions that are trying to define that. No, they're just referencing it. They're just referencing it, and that's fine. You need something that's actually making a label. Or was Make saying? Make might have been saying that they're... Sorry, I do want to get to compiling, or decompiling. But I would like to figure this out. Yeah, as well. Multiple definitions. This isn't actually a definition. It's just a reference. Oh, but this is a good hint, actually. NZ1 load does not have a jump table in it. And so if this is suggesting that it does have a jump table, then it's wrong. Which just tells us that our jump tables are not here yet. And so this is something different then. That's all of our RO data though. Maybe it would be unlikely that can we have no jump tables? That's possible. Let's try it. Let's see if we can get away with no jump tables. We're gonna manually split. It should work because nothing is decompiled. It should be fine. It'll become an issue later on, but it might work now. We don't have the BSS file, and we don't really need BSS file. So we don't have anything in the final build. Why? I'm guessing sim export got rewritten. Oh, it didn't. Well, yeah, that's odd. So the sim export file should tell the linker where to find a function, and basically the linker then will walk all the references there. But that's not working. All right, so I'm gonna put this aside. Something untoward is happening with NZ1. Oh, we don't even have an NZ1 load? Well, that could be the issue. Now I'm confused. I thought we did have this. Yeah, we do have an NZ1 load. But it's not being included here, which is odd. So let's look at what is nearby. This function, the offset's wrong. So I wonder if all these function offsets are... Yes, all these function offsets are broken. Oh, and that's because match config. I don't really want to keep... I'm going to stop working on this. The issue was when matching is done, the wrong VRAM address was given, and so that just breaks everything, and nothing ends up matching. That stinks. Drat. And so if we look at the VRAM header, I'm not sure. I do know what was passed there, though. Looks like it's off by 80 bytes, which sucks. Okay, so I'm done. Done stressing about that. We're gonna go stress about Harpies instead. So Harpies, we were about 85% of the way to matching that file. A couple ordering things. I do like to get the PSP version for that, and we can find the function in PSP, find the correct VRAM address for it. I think our VRAM addresses are correct there. Make sure that it's aligned properly, and add that symbol as well. We can start accumulating symbols as this goes. Sound effect IDs are really good for finding these files, and we should be able to hopefully get a matching file with that. Value in it. When it doesn't work, the reason it usually doesn't work is because the sound effect has changed or is offset differently from one version of the game or the other. So I'm going to try a couple of these. Are we really not going to be able to match any of these? Oh, I'm looking at matchings. That's why. It shows up in matchings because it couldn't find the entry in the C file, and it couldn't find the entry in the C file because all the offsets are wrong. All right, so I'm going to look at for this 78B file. I think that's going to, or sound effect, I think that's going to be the most unique, and it's here. So when we're looking at this function, this is going to be our entity harpy. We do want to make sure that we're starting with something that adjusts the stack pointer, and we're ending with something that does a JRRA. Those are pretty good indications that we're at the right place, and I'm pretty sure the alignment for this is correct, so this is the correct address for entity harpy. So even though some of this other stuff is wrong, I'm pretty confident in this. Famous last words. And let's see if we can find that. Should be able to find the function here. And let's start a new scratch and decomp.me with for the harpy. Congratulations, Supreme Quetzal, on your pass. A B in Calc is better than the vast majority of people will ever do. Integrals can suck it. I never minded integrals. I thought those were okay. Did that class have differential equations in it? So quite a ways away from a match on the PSP, and that's good. We'll get something close, if not perfect, and then we can match both of them. The big issue here probably is related to types, and so we'll reference M2C's output. But along the way, we get a bunch of symbols, and these addresses are baked in, so we know that those addresses are correct as well. And so this is the reason I wanted to get the PSP version this time, because this was super helpful last time. I think we should have set step. We don't have that as a symbol anyway. Play positional, play SFX positional, is that there? No. Some of these are odd that they weren't able to be found. Initialize entity we should have. That's not in here either. I will have to go look. When I was writing the MIPS match tool, I was primarily focused on the PlayStation, and so there may be some instructions that don't work very well for the PSP. It has to mask out a bunch of information from instructions, and sometimes if it doesn't know details about the instruction, it might not be able to do that. This is... Oh, I'm screwing up. Looking at the wrong place. Initialize entity was correct. So our start is pretty good. We do have this var A0 getting set to FF. It does look like that is something that will be relevant. And where is that used? It's used down at case 5. The other thing I mentioned yesterday is the cases were out of order. That doesn't mean that they're wrong. Just odd, but it does look like the case order is the same between the two versions of the game. So I guess there's no issues there. Let's get that var A0 value set down here in case 5. I'm going to update the context with the correct signature. Right before the stream ended yesterday, there was a question regarding the set no reorder option that appears at the top of a bunch of these assembly files. But then when we do have branch delay slots, there are still no ops there. And why is that? I mean, it really depends on the compiler. So set no reorder tells the further stages in the compilation pipeline. It could be at assembly, it could be at linking. Don't move instructions into the branch delay slot that aren't already there. So if the compiler generated a no op for that, just leave the no op there. Don't try to optimize that. The reason that we have that option set is we need this to compile back down to exactly what we disassembled, so we need to be able to round trip it. And the way that we can ensure that we can round trip it is by making sure that no stages in the compiler pipeline muck with the ordering of things. All right, so I'm looking at case 5, if I can find it. And I want to see where this equivalent logic is. It looks like this is being treated as an argument to get side to player, but there is no argument there. So I think this is kind of a hallucination. Var A0. Yeah, okay. So this is just a temporary register that's being used. It's ends up being for this if statement, which I think is part of the switch and not actually anything that needs to be worried about. So not worried about that at the moment. I think that's just M2C not understanding. All right, so the next things, SP20 is not going to be a second argument because there is no second argument there. This next function is move entity. And so I'm on the side here, I'm adding all these symbols, and then I'll probably re-export with the updated symbols to get something a little cleaner. So far, so good. I don't see anything that's like super alarming. We have an entity extension that we haven't created yet, incrementing the step. Different arguments to this function. I could put this in the context. And then M2C will know not to try to make those arguments. I will add get side to player. There's no assignment here either. Move entity is a void. So some of these basically M2C, if it doesn't have the function signature, it's going to guess based on the registers that are used what the function signature is. And it guesses wrong sometimes. I do want this section up here to untangle that area. I'll grab animate entity. Roaming says he's been helping with some C++ decomp and he misses C. They always come back. C is really bad until you have to program it in a different language. And I think I have enough of these symbols. I'm going to try to go grab all of the symbols first, and then we can go back and generate a new decomp, because there's enough of these that are getting pulled that I think that will be worth it. That might be most of them. Some nice use of absolute value here. That gives us some hints. I'm going to take a break. I'll be right back, and then we'll do a little bit more here. 1 second. All right, back. Thank you for putting up with my delay. So the interesting thing about C++, and correct me if I'm wrong, you should have vtables for all of the objects, right? Which is, I think, kind of interesting. Something a little different that we don't get that on in C. That at least tells you the relationships between structs and structs. I'm sure most of them are classes. I didn't do a lot of interviewing for C and C++ type programming. Interesting. There's no... Oh no, there is a font print there. Okay, so I got a bunch of these symbols. I'm going to extract this again. Oh. Is it? Looks good on my side. Functions can appear and disappear out of nowhere. Oh, that's interesting. I don't know anything at all about C++ compilation. I'm sure there are all kinds of wacky... The language is so wacky and has so many features and tricks that I'm sure that there is all kinds of stuff. All right, let's get... This did not seem to get... Are all these wrong? I have trouble reading these addresses. You really need a decoder for these. So the way the JAL instruction works is 5 bits at the front of the instruction are going to indicate that it's a jump instruction. And the remaining bits, so you have 5 bits for the instruction. I think you have 26 bits for the address. The top 2 bits, no, the bottom 2 bits are just zeros because functions are always aligned on 4-byte boundaries. So you don't have to worry about those. I think the top 2 bits come from the current program counter. And so that gets you up to 30. And so maybe that's your, maybe the top 4 bits come from, yeah, maybe it's the top 4 bits come from the current program counter, because that would give you 32. And unfortunately, the MIPS decoder that I like to use does not decode these correctly. I thought that I went through all of these though, and so I'm a little disappointed. Yeah, I do have this, and so why didn't this get regenerated? I'm worried that I'm going to lose this function, but that's okay. Yeah, unfortunately, this function is no longer being generated. Oh, because yeah, that makes sense because I gave it a name. It's entity harpy, of course. Yeah. Right. So I'm gonna delete this start a new one. Put the function signature in the context from the start. And now we should have most of the function declarations, or the function symbol names, in place. Which will just make it a little easier to read, and when we look at the decomp, a little easier to follow. I'm not terribly concerned about everything that's going on there. I'm going to just look at the diff and try to figure out where things may or may not have gone wrong. So there is at least one more entity variable, and so we're not doing the entity plus one in line. We don't get the move yet, but that's okay. Hopefully that appears eventually. Right now it's just being assigned directly to the variable register. '87 is our next area of concern. So some of these are going to be signed. This looks like it ends up just being a plus equals 20. But there is a mask in there. There are some more variables as well. So this, the temp S0, I'm going to keep. Oh, the mask is happening after the add. Okay, my bad. I have to make sure that the correct sign extensions are happening. And they're not. Let's try this. I'm going to do a plus equals 32. And then do a and equals with a mask. This might be too many assignments back. So there is a sign extension happening. And we do need a variable. So let's grab that temp S0. Is this already? It should be a 32-bit value. And it looks like it's not. Oh, it is. All right, so what's going on? We're doing the plus equals 32. Oh, but this is being assigned here. What order that's happening in, I'm not sure. And then we're doing the mask to that variable. It is being done as a V1, so it's possible that the mask is happening in line, but it's using the same register here, so I'm assuming that it's a variable. We'll see. Otherwise, it would be happening twice. The sign extend. Oh, I'm wrong. Temp S0 should be sign 16, I think. And that gives us the additional sign extensions. I think possibly that this might be so this ends up in the stack pointer, or on the stack instead of in a register. I'm going to keep it that way for now. The mask here tells us that this is a truthy check. Same on 112. Nope, it tells us that it's signed instead of unsigned. 117. It looks like the same thing here. All right, so I'm going to look at what M2C is doing here. This is at case 5. I think all this is fine to here. We have a variable. We'll call this distance x. And I'm sure we'll have distance y. And those are being calculated before anything else. Not quite. So then we do take the result of x, and this var v0 is not used again, so yeah, we can do that inline. The shift by C, that's float to I. And a bunch of this looks like it should just be able to go away, I think. No, actually, it's just out of order. This is a little strange that velocity y is calculated again with a slightly different value. And we don't see the plus temp A. Oh, that's velocity 4, so this ends up being plus equals. And temp V4. All that seems fine. This is odd. So sine is a slightly expensive function. And so to calculate the y velocity and then just throw away that calculation down below is a little strange. But that's what it looks like is happening. Well, this looks fine, just different variables. The shift by 16 is something that GCC does. I'm guessing this is a knot. We'll check it in a second. Oh, that seems fine. Interesting, in both cases, these return after setting the step. I'm gonna try putting the return here and see if that works. And then we can go back and see how close this ended up being. There's a bunch of variables in there that I still don't like, but that's okay. So the first thing is, where are our sine extensions? Are we loading the right things? G entities gets loaded first, but then we're storing back to the stack. So it's a little hard to read at the moment. It almost seems like these are backwards. Let me go back over here and look at them again. G entities. Yeah, so that's the correct order, but the way that G entities, oh, they're pulling the player out into a pointer first, and nope, they're not. Never mind. I'm not sure why that's happening in that order. The fact that these are going to the stack doesn't help readability wise. 131 here. A bunch of this is being recalculated, which doesn't need to have happen. Should fix that up a bit. Again, there's a bunch of stuff on the stack where they should be staying in registers. I'll come back to that in a bit. 136. Looks like this is signed. We should do that for all of them. $137. Looks like temp v0 should be a 32-bit value. Oh, we're not getting some of the... Oh, it's being pushed back to the stack, so it's hard to know. 138. Again, a stack pointer load. We are missing this A0 load. No, it's down there. Never mind. Looks like another case where this should be signed. This looks like a timer. So my guess here is that this is just going to be a not minus minus. Again, stuff getting pushed to the stack. This looks like distance X and distance Y. And as these are used more, it's possible that they're going to be assigned registers. They might not be, possibly not, shouldn't be the same thing. This return looks fine. Looks like there is a return after this. So semantically it's the same, but it doesn't work out to the same code. Not worried about the moves. 173. This looks like it's going to be a plus equals. 100 for rotation. I'm going to keep this as hex 100. This might be a float, like a... Roaming says, unsure about the entity state machines where you have to set things up to ask distance to the player. Yeah. There's a bunch of these functions, and I'm not... So these are the names that we gave them, right? And it could be that we've given them names that make them more confusing than it should be. But how do you know that until you give it a better name or come up with a better name? I don't know. I do want to check in with the PlayStation and see if we're any closer, or if it changed anything at all. Yeah, we got 1% closer. That's good. I don't think we're down here yet, are we? How is the top looking? Where were we? Yeah, we're not down there yet. So the things that are not correct yet, we haven't really gotten to. There is some stuff on 128. No, sorry, 138. This is optimization, putting the shift into the branch delay slot for temp v1. So there needs to be something that happens earlier that cements this not being allowed to be delayed. It looks like there should be a... No, never mind. I was gonna say, I think there should be something to reference this, but it doesn't look like it's happening yet. So some more work to be done, but it doesn't look like a lot of it's going to happen until a few lines down. This is probably going to take a couple days to get through. .182 is going to be the next area that I focus on. Animated entity, I want to see. I think this is fine. Yeah, my function signature is correct. And it's just the moves that are getting me. This has so the order didn't matter for GCC, but the order does matter for M2C. Looks like this is probably getting set as a variable again. Okay, so we're going to call var s3, we're going to call that distance x. And then the other distance looks like it is being calculated in line. There's a facing left check here. Oh no, there's not. We have the 101 check. So this is kind of like a clamp. All right, let's see how that looks. It's like a bunch of extra code around here. So here, entity does look like it is being pulled out. So I'm going to make a player entity pointer. So it looks like distance y is being set up here. I think the subtraction, that makes sense. Instead of negating the entire thing, I think the subtraction is just out of order. And then we get some loads and stores to the stack that shouldn't be there. It looks like... there's a SEH, which means some of these possibly... No, I guess that's fine. There are some conversions back to 16-bit here that I will need to look at a little bit, because is temp fee... Oh, it looks like temp fee 08 should be assigned 16. That's a little weird, because RTAN, or RATAN, returns a 32-bit value, so you're truncating off the bottom 16 bits. And I suppose that's fine, because the top 4 bits are going to be your distance. These are floats then. So 1/16. And the other one's going to be 3/16. Load immediate 2 here. Oh, that's further down. Okay, now we just need to make sure that we're returning to the correct place. Right now, that's probably as good as we're gonna get. And we're doing okay. Just 71%. Let's check the PlayStation. 1 more percent there. Not bad. So I think in general, like getting the structural pieces in place. So this is a plus FF. FF is the same as a minus. Minus. Oh, interesting. We need the masks. $261. I will have to go through and clean up variables as well. We still have a lot of extra variables. But here's the next meat. I still don't have YouTube comments, but I don't mind doing reads once in a while. Roaming says, I just had a C++ moment where marking a virtual function as inline changed where the jump table for a switch statement appeared. Did the function inline anywhere? Nope. But it did fix this data nonsense. Yeah, that does not sound fun. So what made you think to inline? Is that something that is like a known trick that's going to affect things, or something that you've seen before? I tend to not remember tricks like that. Yeah, good. It's always nice to have smart people around. It's amazing some of the tricks that people find. All right, here it looks like we're pulling another player pointer. Loading the X position. And then either doing a subtract or an add. It's like Y is getting loaded here too. I'm gonna go look at M2C's interpretation. No, I was wrong. Maybe not specifically wrong, but let's do this. So these, again, are floats. So using the float macro, I think makes sense. I think it's going to be a float 30. $48. decimal. And I like calling these distance. So there's going to be a bunch of variables in here that may not be correct. Probably need a pause X and a pause Y at some point. I'm going to keep going for now. The moves suggest that these were out in variables, but I'm just going to keep going. Maybe 271. These look like X and Y's. And yeah, it looks like this player position was pulled out earlier. In this case, distance looks like it's assigned 16. And that seems fine. It's not being calculated this way, but it's close enough. More of the same. So this is an apps. So it seems pretty certain that offset 10 and 11 are X and Y values. And I think that they are signed. There's some ordering down here. I think I'm going to end it for now. We got up to 74%, so quite a bit of progress for the PSP. Let's check PlayStation one more time, see if we're any better. Ooh, a little worse. It's okay. I think overall the structure is getting there, and we can focus on the areas that need focus later. So we've been decompiling the Harpy, the villain, one of the worst enemies in the game, and we'll beat this Harpy one way or another. Go check out the Castlevania Symphony of the Night decompilation project. What does invalid code coverage mean in the decomp GitHub repo? That means that we have not started that overlay yet. So there was a YouTube video 2 or 3 months ago now that came to our GitHub page and saw that, so at the time, the invalid entries were not there. We just had the ones that we had started, and they were green or nearly done, and this YouTube video then made the claim that we were nearly done with decompiling Symphony of the Night. And so I added I added all the invalid ones just to communicate that we're not done. We're getting close to halfway, but not quite done yet. Roaming's working with MetroWorks as well. MetroWorks is, yeah, interesting. I've never had any experience. Like, I was aware of Code Warrior back in the like Mac OS 8 and 9 days, but it wasn't something that I ever used. I think it's a little interesting that they kind of got ingrained with a lot of the Sony tooling. I'm assuming Sony has gone back to GCC since then. I don't know anything about the modern Sony tooling, but just based on the rest of the stack, it seems like GCC would make a lot more sense than a proprietary compiler. But that's it. Go to soten.z.dev to learn more. GitHub, Discord, see us there. Hit the like button. Sorry about the technical difficulties this morning. And I will see you all tomorrow. Adios.